Well, imagine walking onto a modern factory floor. You don't just see a bunch of standalone engines revving in the corner.
Right, you'd see a fully coordinated assembly line.
Exactly. Every single sensor, every robotic arm, they're all talking to each other.
Reacting in real time.
Yeah, you aren't just testing a motor, you're manufacturing a product at scale. And, I mean, that is exactly what happened to generative AI between March 8th and 14th, 2026.
It really was a pivot point.
It was. Amazon Bedrock fundamentally shifted. It went from being, a playground for hosting cool AI models into a fully industrialized, enterprise-grade operating system for autonomous agents.
Because we're looking at ultra-fast, disaggregated hardware now,
Right.
we're seeing real-time streaming memory for AI,
Yeah.
and we're tracking strict new security policies to keep it all contained. So for you, the listener, the news out of AWS this week proves that the second wave of AI adoption is officially here.
Not just the hype wave.
Right. This isn't the wave where we generate funny poems. This is the wave where AI actually runs the business.
Welcome to this deep dive. Our mission today is straightforward. We're cutting through the noise to bring you exactly what happened in the AWS Bedrock ecosystem this week.
And there was a lot of noise.
So much. But we've sifted through the official announcements, the architectural white papers, and the security reports to figure out what actually matters to you.
You can really view this week's updates as a masterclass in operationalizing AI. It's about taking the raw potential of foundation models and turning them into reliable, governable digital workers.
But before we can build an autonomous enterprise, we need the right brains for the operation.
The models themselves.
Exactly. Let's look at the new models. If you read the AWS machine learning blog on March 9th, you'd see they just dropped NVIDIA's Nematron 3 Nano.
And that's a global release.
Yes, globally. It's deployed as a fully managed serverless model directly on Amazon Bedrock.
The architectural specs here are what make this really interesting. Nematron 3 Nano has 30 billion total parameters.
It sounds like a lot.
It does, but, and this is the crucial part, only 3 billion of those parameters are active during generation.
Wow, only 10%.
Right. They achieve this using a mixture of experts' architecture. So think of it like a massive corporate office. You have 30 billion employees total, but you don't call all of them into the boardroom to solve a single problem.
That would be chaos.
Exactly. You only call the 3 billion experts who actually know about that specific topic.
Which makes it a highly efficient open-weight option. And by open-weight, we mean developers can actually look under the hood and fine-tune the model's neural network for their own specific data.
Which is heavily optimized for edge deployment.
Or lightweight agent workloads, yeah.
And while AWS is optimizing for efficiency on one end, they're expanding raw capacity on the other.
Also on March 9th.
Right. They announced a massive regional expansion. Anthropic's Claude models, specifically Opus 4.6, Sonnet 4.6, and Haiku 4.5, well, they are now accessible to customers operating from the Mumbai and Hyderabad regions in India.
And they're doing this via global cross-region inference.
Yeah, which is a massive logistical move. It brings a 1 million token context window directly to the Indian market.
Okay, let's unpack this. Are we hitting a wall with massive models? I mean, it seems like adding Nematron 3 Nano proves that smaller, highly specialized models are the actual future for enterprise agents.
It definitely points that way.
Right. You don't always need to throw a trillion parameters at the wall just to classify an invoice or route a customer support ticket.
Yeah.
It feels like we're realizing a sledgehammer isn't the best tool for cracking a nut.
I wouldn't say we're hitting a wall with the large models, but you're absolutely right that the industry is getting smarter about resource allocation. Small models, especially those using that mixture of experts architecture we just talked about, they handle logic and routing perfectly well, and they save massive amounts of compute.
Right.
But here is the harsh reality. Physical compute remains a strict bottleneck.
Always comes down to the hardware.
It does. Even the most efficient model is bound by the speed of the silicon it runs on. If we want these autonomous agents to act instantly, software tweaks just aren't enough anymore. We need a complete overhaul of the physics of AI hardware.
Which is exactly why the hardware announcements this week are so critical. A smart model is useless if it's waiting in line for processing power.
Exactly.
So on March 13th, Amazon Press and Benzinga reported a pretty groundbreaking partnership. AWS and Cerebras systems announced a joint disaggregated inference architecture.
And they are deploying this in AWS data centers right now.
Yeah, and it's accessible exclusively through Amazon Bedrock.
This is a fundamental redesign of how AI actually runs on Metal. They are pairing AWS Trainium servers directly with Cerebras CS3 wafer-scale engines,
And they're connecting these distinct pieces of hardware using elastic fabric adapters.
which is AWS's custom high-bandwidth networking.
The performance metrics they published are wild. I mean, they're achieving up to 3,000 tokens per second.
3,000?
Yeah, alongside a 5 times boost in high-speed token capacity. That completely shatters traditional GPU bottlenecks.
If we connect this to the bigger picture, we have to look at how a model actually generates text. There are two distinct phases in AI inference.
Okay.
First is the prefill phase. This is where the model ingests all your context, so your instructions, the history of the conversation, the data you uploaded.
The background reading.
Exactly. Think of it like reading the textbook before an exam. Then the second phase is the decode phase. This is where the model actually generates the answer, token by token, word by word.
So that's taking the exam.
That's taking the exam.
And traditionally, a single standard GPU is forced to handle both reading the textbook and taking the exam.
Which is highly inefficient. Those two phases require completely different types of computing power.
How so?
Well, the prefill phase, reading the massive textbook, that requires massive compute density. You need to crunch a ton of data all at once. But the decode phase, writing the answer out word by word, requires massive memory bandwidth to keep retrieving the right vocabulary instantly.
Oh, I see.
So what AWS and Cerebras did is disaggregate or separate those tasks onto completely different chips.
So AWS Trainium handles the heavy context ingestion. It reads the textbook.
Right.
Then, over that high-speed network, it hands off the active generation work to the Cerebras CS3.
Yep.
And the CS3 isn't just a normal chip. It's a massive wafer-scale processor that is custom-built to spit out tokens at blinding speed.
It's huge.
So separating these phases onto custom silicon designed specifically for each job is an absolute game changer.
It's the assembly line concept you mentioned at the start. You don't have one worker building the whole car. You have specialized stations.
And here's the pivot. A wafer-scale chip spitting out 3,000 tokens a second is completely useless if the AI glues together the wrong context.
Right. Speed isn't everything.
To handle that kind of speed, the agent needs a completely different kind of memory architecture. Raw intelligence needs a workspace. So moving over to product updates, AWS just gave AI agents a persistent identity and long-term memory.
This is where we shift from a simple chatbot to a true digital worker.
Tell me about it.
On March 10th, AWS announced that AgentCore Runtime now supports stateful model context protocol, or MCP, server features.
And this is live right now across 14 global regions.
The technical implementation here is vital to understand. These stateful sessions run in isolated Firecracker microVMs.
For those who might not know, a microVM is a tiny, incredibly secure virtual machine.
Tiny and fast.
Yeah, Firecracker is the open source technology AWS uses to spin up these environments in a fraction of a second. The server maintains the session context across multiple interactions using a specific session ID header.
This update includes features like elicitation, sampling, and progress notifications, which fundamentally changes the user experience.
How does elicitation work in this context?
Elicitation means the agent can actually pause a complex workflow to ask you a clarifying question. It doesn't just fail or guess. Sampling allows the server to request AI-generated content mid-task.
Nice.
And progress notifications allow the agent to send real-time progress bars back to the user for long tasks.
Like booking complex travel itineraries or pulling massive database queries.
Exactly.
Here's where it gets really interesting. Think about that stateful MCP running in those isolated Firecracker microVMs. It's like giving an AI agent its own secure, locked office with a persistent filing cabinet.
That's a great analogy.
Before this week, agents were essentially working in a public lobby. Every time they finished a single task, their memory got wiped.
Blank slate.
Yeah, they had to start completely fresh with every prompt. Now they have a dedicated private workspace to carry out complex, ongoing projects over hours or days.
And AWS didn't stop at short-term session memory. On March 12th, they announced AgentCore Memory streaming notifications globally across 15 regions.
Streaming notifications.
Yes. AgentCore now pushes long-term memory updates directly to Amazon Kinesis.
So it pushes an update every single time a memory record is created or changed by the agent.
Right. Historically, developers had to write polling logic. Your application had to constantly ask the server, did the agent learn anything new yet? How about now? How about now?
which is so inefficient.
It wastes compute and introduces terrible latency. Now it's an event-driven stream. It's like your GPS just telling you when to turn, rather than you having to constantly check the map.
I love that.
Your applications can instantly and automatically react to new insights the AI learns about a user in real time.
But with all this complexity, I mean, high-speed chips handing off data, microVMs holding memory states, event-driven streams, we absolutely need better observability.
Oh, without a doubt.
An engineer has to be able to monitor this. So on March 10th, Bedrock added 2 native CloudWatch metrics globally. The first is TimeToFirstToken. The second is EstimatedTPMQuotaUsage.
TimeToFirstToken, or TTFT, measures the exact latency from when a request is sent to when the very first token is received back from the streaming API.
That feels like a critical metric.
It is arguably the most crucial metric for user experience.
Because perceived latency matters significantly more than total processing time. If an agent starts typing its response immediately, the user feels like it's working.
Exactly, even if it takes another 10 seconds to finish the paragraph.
Right.
And the second metric tracks your tokens per minute quota consumption. It even calculates cache write tokens and output burn down multipliers.
Which get incredibly complex when you're running heavy enterprise workloads.
They really do.
So operators can now set proactive alarms based on these metrics. You can catch latency degradation or prevent token per minute quota throttling before the end user ever notices a glitch.
You're getting ahead of the problem.
Yeah, you're governing the performance at a systemic factory floor level.
But we need to take a step back here.
Oh.
Giving an AI agent its own office, a persistent memory stream, and blazing fast compute is incredibly powerful. You're giving it autonomy.
Sure.
But autonomy is a massive security risk if not managed correctly. You can't just hand an AI the keys to your database and assume it will behave nicely.
That brings us to the tension we're seeing right now in safety and governance. There's a delicate balance between giving agents the freedom to solve problems and keeping them locked inside strict corporate guardrails.
Exactly.
Between March 9th and 12th, AWS launched policy in Amazon Bedrock AgentCore globally.
This new feature provides deterministic authorization controls. Developers can use natural language to write CEDAR policies that explicitly govern agent behavior.
And for context, CEDAR is an open-source policy language developed by AWS. It allows you to write rules that say exactly who can do what.
It separates the security rules from the agent's internal reasoning.
That is huge.
It really is. It guarantees that an agent cannot access unauthorized tools or data regardless of what the user types into the prompt.
Or regardless of any internal hallucinations the model might have.
Right. You aren't relying on the AI to decide if it should access a file. The CEDAR policy physically blocks it.
And we saw exactly why that strict deterministic separation is necessary this week. On March 13th, InfoSecurity magazine reported on a DNS-based data exfiltration flaw found in the Bedrock sandbox.
Yes. Security researchers demonstrated a clever method to bypass Bedrock AgentCore's sandbox mode network isolation. They utilized DNS resolution to read sensitive S3 data.
But how does that actually work in practice? I mean, how does an AI use a domain name query to smuggle data out of a locked sandbox?
It's a classic exfiltration technique applied to AI. Imagine the agent is trapped in a sandbox, but it has access to a sensitive file, like a customer's password.
Okay.
It can't send an email or make a standard web request to the hacker server because the sandbox firewall blocks it.
Right, it's isolated.
Exactly. However, the sandbox still allows DNS queries so the system can resolve web addresses.
Oh, I see where this is going.
So the compromised agent takes that secret password, attaches it to a web address, and tries to look up something like secret-password.hacker-server.com.
Wow.
The sandbox firewall says, oh, that's just a DNS lookup, and lets the request out. The hacker's DNS server logs the request, and just like that, they've stolen the password without ever establishing a direct connection.
That is incredibly clever. Now, AWS responded to this finding promptly, and it's important we look at both sides here impartially.
Absolutely.
AWS clarified that this specific DNS resolution behavior is actually intentional within their sandbox mode. They stated it's designed for basic testing, not hardened production.
Right.
Subsequently, AWS updated their official documentation.
Yeah.
They now explicitly recommend using VPC mode or virtual private cloud mode for any sensitive workloads.
This raises an important question about the shared responsibility model in the age of agentic AI. As impartial observers reporting on this, we can see how this incident perfectly illustrates why the new CEDAR policy enforcement we just talked about is so critical.
Because the network isn't enough.
Exactly. The security researchers successfully proved that you cannot rely on default network isolation or basic sandboxes alone to govern an intelligent agent.
A sandbox is just a basic perimeter fence. If the agent is smart enough, it will find a way to slip a note through the fence.
Precisely. You must govern the agent's actual identity and its specific permissions using something like Cedar.
Yeah.
Furthermore, AWS is pointing out that customers must take an active role in their network architecture. You have to configure VPCs, disable outbound DNS if it's not needed, and write strict routing rules for sensitive data.
Under the shared responsibility model, the cloud provider secures the infrastructure, but you, the customer, are responsible for securing the configuration.
That's exactly it.
So we have the efficient Neutron models, we have the disaggregated Cerebras hardware, we have the stateful Firecracker workspaces, and the Cedar security policies locking it all down.
It's a lot of pieces.
It is. What does this actually look like when a business puts it all together? Well, on March 11th and 12th, the AWS Machine Learning blog highlighted specific GenAI IDP accelerator implementations.
IDP stands for Intelligent Document Processing.
Right. AWS showcased successful large-scale deployments powered by Bedrock data automation at major enterprises, specifically highlighting Kompetiskin and Ricoh.
The operational numbers here are impressive. Kompetiskin achieved 85% accuracy, processing 45,000 marketing campaigns daily.
45,000 a day.
Yeah. Meanwhile, Ricoh is projecting savings of over 1,900 person-hours annually.
This proves that generative AI is actively replacing brittle, template-based data extraction at scale.
Yeah.
Historically, companies used regular expressions, or regex, to find specific data in a document.
And if the document format changed even slightly, say a vendor moved the invoice total to the left side of the page, the whole system would break. The IDP Accelerator features a unified architecture that uses Bedrock data automation. When a new document format arrives, developers don't have to write a new template.
The model simply reads it, understands the context, and adapts instantly.
Yes.
Think about your own day-to-day work for a second. How much of your week is spent just reading a document, classifying it, and pulling out 3 pieces of data to put into a spreadsheet?
Too much of it.
Way too much. These companies are reclaiming thousands of hours of human potential. They are offloading the mundane, repetitive tasks to an automated system that never sleeps, never complains, and adapts to new formats on the fly.
That is the industrialization we are talking about. We are moving from AI as a party trick to AI as core enterprise infrastructure.
So what does this all mean? Let's recap the through line of this week's news. AWS Bedrock is no longer just serving up text via an API.
Far from it.
By combining disaggregated hardware from Cerebras to shatter speed bottlenecks, stateful memory streams pushing to Kinesis so agents can remember you, and Cedar policy lockdowns enforcing strict identity security, Bedrock has become a true industrial engine.
We are watching the foundation of the autonomous enterprise being poured in real time. I want to leave you with this thought.
Okay.
If an AI agent now has a persistent memory stream, a dedicated and secure microVM to do its thinking, the ability to pause and ask you clarifying questions before it finishes a task, and its own set of security clearances, are we still using software? Or have we crossed the line into managing a digital workforce?
Wow.
Think about how that fundamentally changes your job description moving forward.
A fascinating and slightly daunting question. Thank you for joining us on this deep dive. Keep exploring the material we covered today. And remember that factory floor we talked about at the beginning?
The assembly line is fully operational.
The gears are turning. It's time to figure out exactly what you want to build with it.